Hello, I'm John Roberts. I'm a Redshift specialist at AWS, and I'm here today with Ashley Faber. She's a director of product marketing at Ovation. And today we will be presenting a healthcare industry use case using Amazon Redshift serverless. First, we will cover the use case and then proceed to a demo. In addition to an Amazon Redshift serverless, we will be utilizing data from Ovation. Later on, Ashley will review the data that is available from Ovation in the AWS Marketplace. Lastly, we will then review the AWS solution. Let's get started. The healthcare use case. So gaining insights to develop and enhance products in industries such as the pharmaceutical industry can be difficult. There are many challenges that must be overcome, and for many organizations, it means spending more time deploying, configuring, and managing software and hardware rather than actually analyzing the data. You may have questions like, what market should I focus on? What drugs are patients using? Where should I invest R&D resources? Instead, you are asking questions about software patches, drivers, and optimal configurations. So questions not related to data at all. So the following is a real-world example of how a pharmaceutical company leveraged AWS services to increase the velocity of analytics and also decrease the operational cost over an alternative legacy approach. So this is Katie. She's a director of bioinformatics who needs to access genomic data linked to clinical data to help with early stage drug target research for moderate to severe ulcerative colitis. She decides to explore third-party data available at Amazon Data Exchange to do this. The AWS Data Exchange is a cloud-native service enabling customers to easily find, subscribe to, and use third-party data. There are thousands of data sets available from hundreds of different data providers in the AWS Data Exchange. Ovation is one of those data providers. So if you're not familiar with inflammatory bowel disease or IBD, it is a group of inflammatory conditions in the digestive tract. Crohn's disease and ulcerative colitis are examples of IBD. Ovation's data increases the probability of success for doing drug discovery by enabling the identification and validation of biomarkers and therapeutic targets. Katie finds an affordable and comprehensive data set from Ovation that meets her needs. It has de-identified genomic data for inflammatory bowel disease, including ulcerative colitis. Ovation is an omics data company committed to accelerating the development of precision medicine. Katie is proficient with SQL and really likes the Ovation dataset because it is available with Redshift serverless. She's able to craft a SQL query that delivers the moderate or severe colitis data that was requested of her. Amazon Redshift is the best price performance cloud data warehousing service and integrates directly and easily with other services such as the AWS Data Exchange. Katie's manager, Allison, reviews the analysis, but now has more other questions about the patient cohort. Which severity is the most common for colitis? What other IBD diagnoses are available in the Ovation IBD data set? What are the top drugs for the other diagnoses and severities? So Katie thought she was done, but now realizes that the questions will keep on coming. She decides that building an interactive solution is the best way to provide the answers that Allison is looking for. Katie thinks the solution should be graphical and easy to use so that Allison and others can explore and learn more about the data quickly and accurately. Katie finds that the Amazon QuickSight is a powerful serverless business intelligence tool that will enable her to build a dashboard for Allison and the team so that they can self-serve and gain insights from the Ovation data faster. So Katie builds this dashboard that contains all diagnoses available in the Ovation IBD dataset so that Allison can get answers to other questions she may have. The dashboard also provides severity information with drill down capabilities. Katie then creates a details page of the metrics for each patient. The details page has filter controls so that Allison can filter by diagnosis and severity. The solution uses serverless products in AWS with pay-as-you-go pricing models. The services are fully managed, optimized, and allows Katie to deliver results with a very high velocity. So hopefully you're excited about seeing the demo. I'll proceed to that. And I have a recording of showing how Katie went through the process of building the solution in AWS. So this is the AWS Data Exchange. That's where Katie got started. She logs into AWS and does a search for IBD. That was the type of data that she's looking for. She finds that Ovation has 2 different products listed here, and she clicks on the one on the top there with the clinical data, with a full data set. She subscribes to this product listing, and then notice that the product has 2 different data sets, one through S3 and one through Amazon Redshift Serverless, her preferred method for delivery, since she can use SQL. So she then goes to the AWS console and goes and deploys Redshift Serverless. And this is in the US East 2 region, and you can see that it has the Try Redshift Serverless. For the demo, I've already created this Redshift Serverless in another region, US East 1, so I'll just go to that now. You can see that has the namespace and workspace, and to find the data that was provided through the marketplace, you go to data shares. And then from the data shares, you go on to subscriptions. And the IBD data set from Ovation is one of those subscriptions. She clicks on this and drills down and sees what is available in this data set. It has one schema. I'm sorry, I should say that first, though, you create the database to proceed with using this data set. So she creates a database and clicks create. So that links the data marketplace product to the Redshift Serverless. From here, you can connect to the database and the default dev database. And that way you can then query the data that's available from this external database pointing over to the AWS marketplace. From there, they can see the schemas, the public schema that was shared, and all the IBD data sets or tables from Ovation. She didn't have to create tables. She didn't have to create mappings of schemas and column attributes, any of that. She just started using the data immediately as soon as she created that database using the marketplace subscription. From here, this is Query Editor V2. And so she uses this to query the data. Switched over to the white background for this demo to make it easier for you to be able to see the text here. But these are the queries that she crafted, right? She first found cohorts with colitis, and then she found that there's actually more data available, this metric and value, these key value pairs in the Ovation data set. She then decided to pivot the data to like a crosstab report using separate just SQL. And then lastly, she remembered that Allison really wanted just severe and moderate. So looking at the results that are down here in different tabs, you can see the first query where we found patients with colitis. The second tab showing those key value pairs, right? And so instead of having one row per metric, she decided to pivot that to make it easier to see the 80 patients with colitis with all the different metrics as separate discrete columns. You can see some of them are decimal values and some are integer values are going across to the right. And then lastly, the last tab is the filter with severe and moderate and getting down to the 14 patients in this data set that have severe or moderate colitis. This is what she provided Allison that prompted all those other additional questions. So then Allison decides to build out the full solution with all the patient data that's available. So running these queries, I no longer have a colitis filter and just getting all of the patients, and I'm getting it as that crosstab format. And then this next query showing the diagnosis metrics, which is going to be useful for this graph later on. We'll show kind of a heat map of patients with some different severities. And then lastly, this is the patient drug information. So the number of the types of drugs that patients are actually using for the different kind of conditions and severities they have. You can see here, this is that first tab with all the patient data. The second one is showing the counts of different severities based on the different diagnosis. And then lastly is the types of drugs being used for the different patient population. So instead of just showing this in Query Editor V2, she decides to build out the dashboard that's using QuickSight, Amazon QuickSight. So she goes in the console again to QuickSight, and this is what she created using those three different queries. She created 3 different corresponding data sets. You can do this several different ways within QuickSight, but this was the more straightforward way. Since she already had the SQL query that she crafted, she's just basically copied it and pasted the query here to execute, and then so she can format inside the dashboard. And this is the first query this third query with patient drugs and the patient data and the patient diagnosis crosstab. So then she created a dashboard and the Ovation data analysis dashboard here, and this is what she can use to create this end solution here. And you can see that this first graph shows a bar graph showing the different severity or different diagnoses by severity, make it easier kind of break out the different severity levels for each diagnosis. And then another way to look at that is a heat map. And that's what the next graph below showing diagnosis with the different types of severities associated with it. Makes it quickly to see that colitis, mild colitis is the most common in this data set. And then you can also see the diagnosis and also severity. So on the left here is diagnosis, where you can drill down to the severity level for that particular diagnosis. And then on the right is showing severity for all diagnoses. So you can kind of compare quite quickly and easily different diagnosis severities across different diagnoses. So lastly here, the details page shows the top 10 drugs, and then also all the different metrics associated with that crosstab that we saw, the key value pairs in the crosstab format. And you can see that some of them are formatted as percentage, and others as those integer values. And what's nice by the details page is that I can also filter that. I can say I just want particular diagnoses and see it update dynamically and automatically. And then I can search for other type of severities within those diagnoses. And so it enables the entire team to build out or find other insights associated with the data that's available, because now they have the power to just filter it however they want. So this is the view where you build a dashboard. And so when you then get done with this, you can publish it. And so that way the end user it's not worried with adding elements, they're just consuming it. But they can still have the same parameters that I just demonstrated. And you can see the end result here without those controls for changing the dashboard. But you still have the drill up, drill down capabilities as shown here. And you still have the details page have those same controls where I can filter by diagnosis and also severity. So very quickly I can replicate that same kind of question, or maybe I have a different question about inflammation, right? I can get the information from the data rather quickly and easily. And this is that initial question. I want colitis, and then it's with severe and moderate conditions. And then lastly, I can also do questions in natural language, and this what this QuickSight Q is. And I can ask questions of the different data sets. And this is something that's going above and beyond what's available in the dashboard. I can ask natural language question, and it'll give me information that I was looking for. Patient ID and RX claims at top 10. And you can see that it very quickly produces a graph for me, and I have to that I can still have more controls over that. I can change the measures. I can change the order of the particular, the top 10, either descending or ascending, or I can change the aggregate value from max to count, when count actually made more sense for this particular graph. So you can see it really enables you to ask even more questions that aren't even presented within the dashboard. Hope you enjoyed that demo. And continuing on, would like to pass it over to Ashley, so she will talk about the Ovation data that's available in the AWS Marketplace.
Great. Thank you, John, for that great demo. And thank you all for allowing me a few minutes here to explain some background on all the data that John just presented. So as John mentioned earlier, I'm the Director of Product Marketing at Ovation. We generate high-value omics data, like you just saw, enriched with detailed longitudinal clinical information spanning various therapeutic areas. You just saw IBD, but beyond that as well, at a large scale for life sciences R&D. So just to take a step back, you might be wondering, why does the world even need human genomics, transcriptomics, and generally what we call other omics data? Why is it valuable for pharma researchers to take human samples, extract their DNA, and sequence them? So you may have heard the stat that 90% of drugs fail in clinical trials today, and of course, this is extremely expensive. And when you look at why those failures happen, it's largely due to mistakes in early discovery that don't manifest themselves until much later when patients are already enrolled in a trial. And when you look at why those drugs failed, most failed because they simply were going after the wrong mechanism to begin with. So the molecule might be excellent, but there was not enough understanding of the human biology to ensure it would be successful in practice. And luckily, this is changing because of human genomics data. So applying genomics and other omics data early in that drug discovery process increases the probability that therapies succeed later in clinical development and eventually become available to patients. And that's because having this data provides researchers with valuable insights into the genetic basis of disease, facilitating the identification of better drug targets, which leads to more effective treatments. And that has led to substantial presence of genetic evidence in FDA-approved drugs in recent years. And next slide, please, John. So as, sorry, gotta move it myself. Because of these huge benefits, pharma R&D teams want to get their hands on as much valuable omics data as possible, but it's difficult for them to find data that meets all of their requirements. And this includes having a data set that has enough patients to power their research. This can be especially difficult to find for diseases outside of cancer, like IBD, where there's just not a lot of genomic data today, never mind transcriptomic data. So our use case earlier with Katie, she would have had a tough time finding many data sets available at scale for IBD when she was conducting her search. They're also looking for a data set where every patient is well characterized with curated clinical data, such as all the things that John showed earlier, the treatments that they've had, how severe the disease is, things like that from multiple sources to create a full picture of the story behind the sample. So it's great to take a sample, extract DNA, learn all about the genetics within that sample, but that's pretty useless for IBD drug development if you don't know whether or not this patient had IBD, for example, how severe it is and other factors. And hugely important as well as diverse and inclusive cohorts of underrepresented populations. Having data that only represents European ancestry, which is the norm today, unfortunately, not only limits our ability to translate research into clinical practice, but can really hinder discovery because gene targets may be easier to find in certain groups while holding biological relevance for a broad population. And finally, they want a data set with all of these requirements and they want it like yesterday. So many omics data sets are generated from setting up clinical trials and collecting samples, which can take years and is really expensive. So it's a huge benefit to be able to go on something like the Amazon Data Exchange and just pull that data set right away and get started. Oh, next slide, please, John. Great. And this is why Ovation exists. We're filling these gaps by providing pharma teams with access to high value, large scale, diverse omics data. And we're able to do this quickly because we already have a biobank of 1.6 million consented patient samples. And we have built supply chain technology around it to de-identify, tokenize these samples so they can be linked to almost any source of clinical data like you saw earlier. And that 1.6 million patient biobank comes from a network of CLIA certified labs that serve a diverse patient population across the country. So on a continuous basis, these labs transfer residual samples that are, blood, tissue, swabs for all sorts of diseases to Ovation's biobank to be de-identified after clinical testing has been completed. And the type of omics data that we offer depends on the disease specific cohort. Currently, we're producing whole genome sequencing, whole exome sequencing, and RNA sequencing data sets paired with clinical data. What you saw earlier was whole genome sequencing and RNA sequencing paired with clinical data. And for clinical data, we have the ability to work with whichever real-world data provider. So this is de-identified data from real medical records, insurance claims, et cetera. Whichever data sets give the most power to the samples that we have for a particular disease. But we work with top names in the industry to create these curated cohorts. And next slide, please. Great. So just double clicking on the data cohort that John was showing earlier, we have a cohort of 3,000 inflammatory bowel disease patients scheduled to be sequenced this year, with 212 currently available for immediate access on Amazon Data Exchange, like John showed. So this includes, like I just said, high depth whole genome sequencing and RNA sequencing on normal and diseased tissue, linked to clinical data that's relevant for IBD. So treatment exposures, pathology reports, other diagnoses, and disease severity assessed from pathology are just some examples of that. In addition to our initial cohort, we can also generate novel data sets by sequencing material from our biobank of thousands of paired normal and diseased IBD tissue samples and non-IBD healthy controls, all indexed with clinical annotations so that ideal cohort can be handpicked for sequencing. And I should mention that this is a diverse cohort representative of US population with over 1,100 patients from non-European ancestry. Next slide. And we have a free sample data set of 10 patients that is available on AWS Data Exchange for healthcare and life sciences researchers. So we encourage you to check this out, similar to how John did earlier, run and review custom variant annotation, assess the robustness of the clinical data. I'm sure many other use cases you can come up with. So encourage you to check that out. And that's all for me. So thank you for the time, and I will pass it back to John.
Great, thank you so much. And moving on, we'd like to describe the AWS service solution. So we talked about the AWS Data Exchange. This is what really was the genesis of this demo, right? It bridges the gap between providers and subscribers exchanging data. It helps customers lower costs, become more agile, and innovate faster. We also use Amazon Redshift, which is a fully managed petabyte scale data warehouse service in the cloud. It is available both as provisioned cluster or serverless, as we demonstrated here. The AWS Data Exchange for Redshift is one of the many ways data providers can publish data. It gives customers access to live, ready-to-use tables to query and analyze in services like Amazon Redshift as soon as they subscribe. Data providers such as Ovation publishes data in Redshift and shares this through the AWS Data Exchange. Data consumers can then purchase the data through subscriptions in the AWS Data Exchange. Lastly, we used Amazon QuickSight. It really enables BI for everyone in the organization. It is built on serverless architecture that enables consumption-based pricing and auto scale. Amazon QuickSight is a unified, modern solution to author the entire experience from data connections to data preparation to analysis to dashboards and insights delivered in multiple forms of delivery. I hope you enjoyed this quick demo of how AWS services like the AWS Data Exchange, Amazon Redshift, and AWS QuickSight can increase analytics velocity. It really is amazing how AWS empowers users so they can focus on data. So thank you so much. I really do appreciate your time today and hope you enjoyed the presentation and demo. Thank you.
Thank you.